Friction.
Force of friction. Have you seen a rolling ball? A ball rolling down on ground comes to rest on its own. No one is applying a force to stop the motion. Can you identify the force? This unknown force is called friction. When an object moves over a surface, then due to contact between the surface and the object, the surface imparts a force on the object in a direction opposite to that of moving object. Let's see more examples of force of friction. A book pushed on a table moves as long as push is there. It is the friction between the book and surface of the table which opposes the motion of book on table. A bicycle comes to a halt as soon as one stops pedaling it. It is the friction between bicycle's tires and road surface which opposes the motion of tires on the road. On a carom board, the striker, once pushed, comes to rest on its own. It is the friction between striker and carom board's surfaces which opposes the motion of striker. Is the friction the same for all the surfaces? Does it depend on the smoothness of the surfaces? Factors affecting force of friction. Look at the plastic ball and a marble. Let's first roll the marble. Mark the line where marble stops. Now, roll the plastic ball. Mark the line. What do you observe? Marble covers more distance than that of plastic ball. So we can conclude that different objects moving on a same material surface cover different distances. Now we will change the surface and keep the object same. Note the change carefully. What do you observe? Plastic ball covers more distance on newspaper than that on towel. So we can conclude that same moving object covers different distances on different material surfaces. Can we measure this force of friction? Yes, we can measure it with help of spring balance. When an object is hanged on its hook, a hook is pulled by applying a force on it. Then spring stretches and the pointer moves over the graduated scale. The position of pointer indicates the force acting on the object connected to the hook. Now let's perform one experiment with the help of spring balance. Note the reading of spring balance just when wooden block starts moving in two cases. Do you find any difference in the reading of spring balance in two cases? Spring balance shows that less force is required to pull the wooden box when it lies on a smooth surface. So we can conclude that smooth surfaces offer less force of friction than rough surfaces. The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. The force required to keep the object moving with the same speed is a measure of sliding friction. Summary. Let us summarize what we have learned. When an object moves over a surface, then due to contact between the surface and the object, the surface imparts a force on the object in a direction opposite to that of moving object. This unknown force is called friction. Spring balance is a device used for measuring the force acting on an object. Friction is caused by the irregularities on the two surfaces in contact. The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. The force required to keep the object moving with the same speed is a measure of sliding friction.